So next topic is Newton's law of collision of elastic bodies. Now what it states that when two moving bodies collides with each other, their velocity of separation bears a constant ratio to their velocity of approach. Now what is velocity of separation? Velocity of separation is the relative velocity between two bodies after collision. And what is the velocity of approach? Velocity of approach is the relative velocity of two bodies before collision. So when we'll take ratio of these two velocities, velocity of separation and velocity of approach, so they will always remain constant and that value is equal to E. Now this E value is called as coefficient of restitution, and this E value for elastic collision, that means for elastic body, this value will always equal to 1. What it means? It means whenever there is collision occurs between two elastic bodies, so their relative velocity after collision and before collision will always be equal. So when it is equal, so always you will get ratio is equal to 1. Now if there is plastic collision occurs between the bodies, so this E value will be equal to 0. Why this E value equal to 0 for plastic collision? Because for plastic collision velocity of separation will be 0. So when velocity of separation will be 0, so this parameter will be equal to 0 and divide by initial velocity. Obviously there will be some initial velocity, because of that there occurs collision, so 0 divided by some value, so this you will get coefficient of restitution is equal to 0. And the bodies which are inelastic, so there occurs inelastic collision. So for inelastic collisions, this E value always vary between 0 to 1. So this is what we called as coefficient of restitution, which is E. So what it is the ratio of velocity of separation to the velocity of approach for colliding bodies. Now always remember, either it is coefficient of restitution or it is conservation of momentum. These two equations, conservation of momentum, which is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, and this is equation number 2, which is v2 minus v1 upon u1 minus u2 is equal to E. So these two equations will always be applicable along the line of impact. Always remember, coefficient of restitution and conservation of momentum will be always taken along line of impact. Now suppose there is a collision occurs between a ball and a ground. Now in this case the ball is having some initial velocity, say u1. After collision it will rebound and it will have some velocity which is v1. Now in this case u2 is 0 and v2 will be always 0. So when we'll put in this equation, so again we'll get coefficient of restitution for the case when second body is always at rest before and after collision. So in that case we'll get minus v1 upon u1. Okay, so this is the case, this is the coefficient of restitution for the case when second body is always at rest. Now you will ask that why it is minus. So always remember, either we are taking conservation of momentum equation or we are taking coefficient of restitution. So we'll have to always take the velocity directions. Here initial velocity u1 was in down direction, so let it is positive, but v1 will be in upside direction, so that will be negative. So when we'll use this term, so in that case we'll put v1 is equal to minus, so E will come plus value. Keep remember, E will never be in negative. So this is how we can use the coefficient of restitution for the case when there occurs a collision between two bodies in which second body is at rest. Now next is to prove coefficient of restitution, which is the ratio of velocity of separation to the velocity of approach. Now for that we need to understand this sequence. Now here what I have shown, see, body A is there and body B is there. So these bodies are moving in certain direction, so there occurs some collision. Now yesterday I told you in this graph, so when in this graph what we seen, there are two impulse, so impulse is divided in two ways. So on the left side that impulse was causing the maximum compression in the two colliding bodies. So this was called as deforming impulse. So this deformation impulse is denoted by PDT, and after the maximum compression, now the both bodies will try to rebound. So after that there occurs a separation. So this was called as restitution impulse or rebounding impulse. So rebounding impulse is shown by RDT. So what is happening here? Now first the both bodies will collide. So when they will collide, they will try to compress each other. So there will be deforming impulse act on the bodies. After that, when maximum compression reaches, so the both bodies will have same velocity, which is v. After that, next half portion of the impulse, so that will cause restitution impulse. So that will help in the bodies to separate with each other. So there, after the both bodies will move with different velocities in the direction. So this is the sequence of collision, and we call it as phenomena of collision. Now for deriving the coefficient of restitution, what we need to do, we need to apply here the conservation equation. So how we will apply here? So let's see step by step. Now first is, so we need to first apply for body 1. So body 1 is having mass ma and velocity va. So we'll write down ma va for initial condition, which is the initial momentum of body A. Now in this case, the deforming impulse acting on body A, which is minus of P into dt. So when we'll add this impulse, so what we'll get? Now after this impulse, the both bodies are moving with velocity v. So for body A, we'll get ma into v. So this is equation number 1. Please take pen and register with you while having this derivation, because this is important and you need to note down step by step. So this we have write down the equation, which is impulse equation, impulse momentum relation. So what is happening there? Initially for mass A, there is initial momentum ma va, because initial velocity was va. Now there was impulse, you can see effect of B on A. So on A, impulse is minus PDT. So we add this impulse. So after adding this impulse, we'll get the final momentum, which is MAVA. Now we'll start with another equation. What is happening after this? After this, on the same momentum, which is MA into V, now we'll add this impulse, which is rebounding impulse. So minus R dt, that will be equal to, so when we'll add this rebounding impulse, so what it will give to us? This will give us MA VA 2. This is the final separation case. So this is equation number 2 we'll get. Hope you understand. So what we have done, so we are going in series. So first we have taken equation for this sequence, and then we have taken equation for this sequence. Now here in this case there is deforming impulse, so we add deforming impulse to the initial momentum, so we'll get this momentum. Now after that there will be rebounding impulse, so we add rebounding impulse to the this momentum, and then we'll get the final momentum of body 1. So keep remember, these two equations are for body 1. Now for body 1 we need to have coefficient of restitution. So always remember, coefficient of restitution is the ratio of rebounding impulse to the deforming impulse. So from equation 1 and equation 2 we'll get the value of p dt will take on the right side and this will take on the left side. Again from equation number 2 we'll take this term on the right side and this term on the left side. So we'll get rdt value and pdt value for body 1. So after that E is equal to rdt, which is rebounding impulse, upon p dt. So when we will divide these two terms, so we'll get coefficient of restitution for body 1, and this value will get equal to V minus VA2 upon VA1 minus V. Say equation number 3. So this will get, after getting RDT value and PDT value from equation number 1 and equation number 2, and we divide those two terms like here, and we'll get E value. So put it equation number 3. Now next is the same equation we need to write down for body 2. Now for body 2, initial momentum is mb into vb for 1. Now on body 2, you can see there is impulse which is pdt. You can see here effect of A on B, which is pdt. So it will be plus pdt, and that will give us mb into v, similar way as we have done for body 1. Now this is equation number 4. At the same time, now next we'll write down equation for this. So what we'll do, again we'll have mb into v. Now we'll add rebounding impulse, which is rdt. Keep remember, for body B, the deforming impulse is pdt and rebounding impulse is rdt. So this will give us final momentum of body after separation, mb into vb2. So this equation number 5. Now again from these two equation number 4 and equation number 5, we'll get the value of pdt and rdt. How? We'll take these two terms on the right side. So after getting this, again we'll find out the value of E. So E will be, now this time E value will be equal to VB2, because mass will be cancelled out, VB2 minus V upon V minus VB1. So let this equation is equal to equation number 6. So this is how we'll calculate E values for both bodies individually. Now what we need to do, from equation number 3 and equation number 6, we need to find out the value of V. So if we'll take, remember equation number 3. So if we'll take equation number 3, which was for body 1. So from equation number 3, what we'll get? We'll get equation, we got, it is V minus VA2 upon VA1 minus V. This was equation number 3, which was equal to E. So from this equation we'll find out the value of V. So what we need to do now, we need to find out the value of V from equation number 3 as well as value of V from equation number 6. So we will equate those equations, because those equations are equal to V. So when we will equate, finally we will get the value of E. So this, from this equation we will get value of V, which is equal to, we can find out VA. So how will get the value of V from here? So we'll get E VA1 plus VA2 upon 1 plus E. So from this equation we'll get this E value. This is equation number 3. So from here we'll get V value is equal to this one. Now put it equation number 7. Now in the similar way, from equation number 6 we'll get V value. How? So using equation number 6 was VB2 minus V upon V minus VB1, that was equal to E. Now this is equation number 6. So from here we'll again get the value of V. So we will get here VB2 plus E VB1 upon E plus 1. So let's say this is equation number 8. So equation number 7 and equation number 8. When you will equate these two equations, so finally we will get E, which is coefficient of restitution. So that finally will get VB2 minus VA2 upon VA1 minus VB1, and this you can see, this is what coefficient of restitution definition. So you can see here the velocity of separation, body B is having velocity VB2, body A is having final velocity VA2. So their velocity, relative velocity or velocity of separation is this one, and initially they were moving with velocity VA1 and VB1. So their velocity before collision was VA1 minus VB1. So this finally got by this derivation. Hope you understand all the things. Thank you very much.